G'day team and welcome back to some more sequences and series, and today we are going to actually start looking at series. So we've done a whole heap of work with sequences, so now it's time to sort of develop that into series. So a series is defined to be the sum of a sequence. Okay, so all of the terms in a sequence we add together, and that is our series. So for a finite sequence with n terms, so t1 up to tn, the sum of the series is Sn, so S subscript n, that's our sum, and it's T1 plus T2 plus T3 all the way up to plus Tn. Now for an infinite series, which we'll look at a little bit later, so Sn is T1 and it just keeps on going, the sum won't be able to be found, but we can find what the series will converge to. So it won't quite get there, but we can see what it will end up being. So just a little bit of notation just to start off. So we're going to start using sigma notation. So this big E, capital E looking thing is called sigma, and that just means the sum. Okay, so T1 plus T2 plus T3 plus all the way up to Tn is equal to the sum as from k equals 1 up to n, so 1 up to n, of T subscript k. So this k is changing from 1 to n, as you can see here. So like I said, this reads the sum of all numbers of the form tk, where k is 1, 2, 3, all the way up to n. So we'll practice sort of using this notation a little bit, but first just some properties of sigma notation. So if I have the sum of two sequences inside my summation notation, we can split that up and find the sum of the individual sequences and add those results together. Now that's a lot easier to do than adding two sequences together. Now, we also have, if we multiply a sequence by a constant term, we can pull that constant term out and then multiply by the sum. And then the sum, or the series, and the sum of just a constant term to the power of n is just c times by n. All right, so there's just a few properties that you may encounter and use later on. So let's look at an example. So consider the sequence 1, 8, 27, 64, and so on. Write an expression for Sn and find Sn for n equals 1, 2, and 3. Now, this is all about identifying patterns and trying to find our general term formula. Because if we can find Tn, it's really easy to put into sigma notation. So what I can notice here is these are all cubed numbers. So this is actually 1 cubed, 2 cubed, 3 cubed, 4 cubed, and so on. So what this is actually n to the power of 3. Okay, so all of these are n to the power of 3. This is n equals 1, n equals 2, n equals 3, n equals 4. So now that we have a general term, so this is actually Tn equals n cubed, okay? So all we have to do now, write our sigma notation, k equals 1 up to n, and we just change, we write our general term, but we change the n to a k, and that's just like that. All right, so that is all we have to do for this. All right, so that's it. So this is Sn is equal to that. All right, now find Sn for n equals 1, 2, and 3. So S1 is k equals 1 up to 1 of k cubed, and this just means writing 1 cubed, which is 1. S2, all right, so that's k equals 1 up to 2 of k cubed. Now this is 1 cubed plus 2 cubed. Now see how we're just going up from k equals 1 to the limit and just substituting in. Oh, this should be a 3, not a k. So this is 1 plus 8, which is equal to 9. And then S3, same thing, k equals 1 up to 3 of k cubed. That's just 1 cubed plus 2 cubed plus 3 cubed. And this is equal to 1 plus 8 plus 27, which is equal to 36. All right, so that's just a bit of practice expanding and using. So let's have a look at a couple more examples. So expand and evaluate. So we want to find S of 5 because that is my upper limit here. Now that is equal to 3 times by 1 plus 2. So substituting k equals 1. Then we substitute in k equals 2. plus 2 plus, and then we just keep going until we have k equals 5 substituted in, plus 2 plus 3 times by 5 plus 2. All right, now we simplify where we can. So 5 plus, and then 6 plus 2 is 8. And then we got 11. So we're going up by 3 to 17. Now we add these together. So 5 plus 8 is 13. Plus 11 is 24. 38, 58, add 7 is 65. Okay, so S5 equals 65. Now let's have a look at this one here. So S4, because the upper limit is 4, 2 times by 1 squared plus 2 times by 2 squared plus 2 times by 3 squared plus 2 times by 4 squared. So this is just 2 plus 8. 3 squared is 9, so 18. 4 squared is 16, so 32. So S4 is 10, 28, 58, 60. All right, it's as easy as that. Just expand out and substitute k equals 1 and up to your number. Hopefully this helps with series, and in the next one, we'll look at arithmetic series. Catch you then.